Hey guys, Professor Doney back here and starting the next series in projectile motion. Okay, again, projectile motion for us is when an object is projected and it lands somewhere else. To do that, typically we have to throw something up at the same time we throw something over. We could be in a moving car and toss it up, or we just throw it up. The result of throwing it over and up at the same time would be sort of the idea of going off a ramp. Just grab pink here. So we throw it over and up at the same time. The result, as we saw with trig, is throwing something at an angle. Now when we deal with projectile motion problems where it is shot at an angle, or even if it just drives off the side of a cliff and it lands somewhere else, it doesn't fall right below, we have to break it into the x or horizontal and the vertical, which is y, either up or down or both. Now the key to projectile motion is knowing that if the object is in the air, or once the object's in the air, once it's been projected and it's no longer on the ground, if I'm in my car, once I'm in the air, I can step on the accelerator, hit the brakes. It doesn't change my motion. I can't speed up by hitting the gas. I can't slow down by hitting the brakes. So once we're in the air, we find the acceleration horizontally is zero. I can't speed up or slow down. Whatever speed I'm going at when I leave the cliff is how fast I'm going. So if I go through all these and make that zero, all these equations reduce to, if that becomes zero, reduce to v equals VO, final equals initial, final squared equals initial squared, and distance equals initial times, distance equals initial velocity in the x direction times time that's in the air. This is the only equation we have when we look at the horizontal motion. This is going to tell us how far. This is its velocity initially in the x, meaning how fast is it going horizontally. That's the horizontal velocity. And that time is how much time or how long the object's in the air. That'll tell us how far away. If we know how fast it's going horizontally, how long it's in the air, it's basically that. Now vertically, if we have some vertical motion associated with it, we have to worry about finding things like time up here, and we have to use gravity, and we have to pick positive or negative depending on which way we go. So we're going to start out here in a moment with the first problem of just driving off a cliff. I'll just introduce that right now. There's our car. We're driving off the cliff with some initial velocity in the x direction, and because of gravity pulls us down towards the ground, and we eventually hit the ground or land in the water. Okay. We do not go straight. Why? Because gravity pulls us. Gravity is pulling down on us. Do we have projectile motion? Absolutely. This object projects or lands a distance away from where it started. And is it two-dimensional motion? Absolutely. Why do we know it's two-dimensional motion? Because when it goes off the ramp or off the cliff, it is moving in the x, and we see that it falls in the y. So it goes in both dimensions, or both directions. So this is a projectile motion problem. So the way we look at this is look at what's happening horizontally, and then we have to look and see what's doing vertically, and we usually find the time from all the vertical stuff, and then we will find out how long it's in the air. When it drops, we'll take that time, kick it back in here, multiply it by its initial velocity, which we know how fast we're driving off, and we can find out how far away the object lands. Now there's a couple other ways to do this. Splitting it up tends to be the easiest. The book again will use sort of one equation to find everything sometimes, but we'll look at that in the next installment as we introduce projectile motion. Alright, we'll see you in a bit.